everyone. I am Adetunji, your physics tutor. So I greet you, welcome to physics classroom with Estimator Adetunji. For our new viewers, those are those people watching our channel for the first time. So welcome. Please do well to press your subscribe button, switch on your notification button, press your like button, share the program, and likewise put your comment or the topic you want us to treat in the comment section. For our existing viewers, so welcome back. So today in the physics classroom, we want to start a series, a topic that may take us maybe to like 3 or 4 series. The topic is called capacitor. Why are we doing all these things? That we like simplifying topics so that our learners or everybody watching us will be able to enjoy all subjects that we are giving out here with ease. They are very simple. That's why I want us to be breaking them down one after the other. So without wasting time, the topic is capacitor. The next question will be, what is capacitor? I am very glad to tell you that a capacitor is a device that stores electric charge. A device that stores electric charge. I would have loved to state my objective, that what I want to achieve in this series 1, but I think I will do that here in the box with that limited time. I want to achieve the definition. I want to achieve the explanation itself. And likewise, I want to achieve the factors affecting capacitors. So I think the 3 things I want to achieve within this video or this part 1. I say a capacitor is a device that stores electric charge. That's its own function. That's what it does. And the next will now be, I should be explaining what capacitors is about. This is the diagram for capacitor. You have 2 plates of equal size. 2 plates. No one is bigger than the other. This is what we call capacitor. Now, in between the capacitors, we have space. And that space is called dielectric. That's the space, we call it dielectric. Now, the space between, we call it dielectric. And at times, you want to take it further, so we call it, some may say, be talking about dielectric constant, but we'll be doing everything orderly so that we're able to enjoy. Now, moving forward again, we have something called capacitance. When you talk about capacitance, we are still talking about the same thing. It's like I'm saying capacitor is a noun, and while capacitance is like an adjective. So it's still talking about the ability. That is, capacitor means ability. Ability of capacitor. Ability of capacitor to store. Ability of capacitor to store. We know capacitor to store. So that ability to store, the electric charge is what we call the capacitance. Ability of the capacitor to store electric charge. That's what we call capacitance. And it is measured in farad. That is, the unit is farad. Please, there is a difference between Faraday and farad. Farad is a unit of capacitor, that is F. Another notice, take notice of these things. Notice of notation. If I write 1 millifarad, what does it mean? Milli means divided by 1000, that is 10 raised power minus 3 farad. There is no way you'll be writing exams you've been talking about all these things. That's why I need to spell them out. Another one you talk about, if I say 1 microfarad, microfarad is talking about 6 10 raised that is divided by 1 million. If I talk about nanofarad, means divided by 1 billion, that is 10 raised power minus 9 farad. If I talk about pico, that is 1 pico, that is referring to 10 raised power minus 12. So it can be used anyhow. This is the interpretation of all those things. So leaving that side, I think I can now move to what we refer to my factors affecting capacitors. That's my third objective. What are the factors affecting capacitors? Those of you that you have been missing our video, please do well to watch our previous videos. A lot of videos that are in your catching fun with physics. Check our playlist. We see a lot of topics good for you as a learner. And likewise, our professional colleagues online, we always really appreciate you for being there for us, for that love you have for us. We always receive your message. It shows that we are together, we are one. Thanks for the love. Thanks for the assistance. So, factors affecting capacitors, let me say that, or factors, or let me say, we can also say capacitance of capacitors depends on the following. We are saying the same thing. I can say factors affecting capacitors or affecting capacitance of capacitor. We are saying the same thing. Maybe I should spell it like that. Capacitance of capacitors. Number one factor, because of time, I have number one as area. I have number one as area of the plates. Area of the plates. And the next will now be, how does the area of the plate affect area of the plate? It affects, that is inverse, that is capacitance. That's a inverse is directly proportional. Capacitance is directly proportional. Is directly proportional to area, that is C, that proportional to A. Those of us that we are writing exam like a jam that they like dealing with relationship, please take notice. So in that situation, that's relationship. I can call this one equation 1. If I want to take it further, for those of you that are doing mathematics or jam, you know what it means, but I will still combine it together because of my time. Number 2, I can say the distance between the plates. The distance between the plates. The distance between the plates. That is small letter d. How does it affect? That one is inverse. That is the higher the capacitance, the lower the distance. That is inverse. Inversely proportional. Inversely proportional to the inversely proportional to the to the distance. To the distance. That is C is inversely proportional to D, equation 2. I will make it 2. I will still have some other one. We can say we have nature of the dielectric, but that one, I will talk about that one when we are bringing down our relationship. Nature of the dielectric substance. Nature of the dielectric separating plates. Separating plates. That's that. Now, combine. Let me now combine equation 1 and 2 so that we get somewhere. Combine equation 1 and 2. Combine 1 and 2. I want to combine equation. So combining equation 1 and 2, my equation 1 says C is directly proportional to A, while equation 2 said C is inversely proportional to D. So finally I'll be having C directly proportional to A, inversely proportional to D. So according to mathematicians, C equals to K, my constant, A over D. Because in this topic, in this concept, our K, which is a constant, we use a permittivity symbol to represent it, because this thing means permittivity, which is our constant. Permittivity of the dielectric. Remember the nature separating them. Permittivity of the dielectric, that's it. Permittivity of the dielectric. So which means I can say C equals to E over D. If you like, you can put notes there. So this is a formula that relates all the factors affecting the capacitance of capacitor. There are a lot of questions they can ask you there, which I will also put in your screen now, that will make me to understand. How can they ask you a question on it? This is 4 parameters, but before I go there, I need to let you know that permittivity of a free space is a constant, and it has a value. They will always give you the value. Now, that is, we have a common one. For that free space is 8.85, some other number, just approximately, times 10 raised to power minus 12 farad per meter rather. So that is that. So how would they ask you a question on this? They will ask a question on this how? By telling you maybe out of these 4 parameters, this question will be given, it will remain 3. They will give you any 2. They now tell you to find the last one. So that's how it is. I also get a question, at least from JAMB or WAEC or ICSE, to back it up now. Now, here's a question to back up our teaching for today or for this series. We have a question right here saying that a parallel plate capacitor. Please, anytime you are solving questions, that is calculation in nature, try to read through the lines and interpret. That's the best way to enjoy calculations. A parallel plate capacitor of plate 20 centimeters square. Let's interpret that and do it together. You need to query any figure you see. 20 centimeters square represents, well, that is area. Even from the unit you can see area. We have area given. Area is 20 centimeters square. I and you, we know that the standard unit we use in physics is meter. We need to convert this area to meter. This is centimeter. 100 centimeter make 1 meter. So for you now to square it, so now this thing becomes 10,000. That is, we are going to have 20 times 10 raised to power minus 4. I'll take it again. Assuming it is centimeter, it will have been divided by 100, which means 20 times 10 raised to power minus 2. But now it has been squared. So that's why we are having 10 raised to power minus 4 indices. So meter square, we have converted this. We continue our statement. They said in vacuum, as a capacitance of 0.2, the C is 0.2 microfarad, and I've told us again the meaning of this symbol, that it means 10 raised to power minus 6. Please take your time to calm down and likewise go through all these things gently, and give us a constant, permittivity constant, as this time around they give us 9 times 10 raised to power minus 12 farad per meter. We are now told to find the D. Like how we have been taught, we know our formula is E A over D. Let me say that in a simple way you understand. And what's our C? 0.02 times 10 raised to power minus 6 equals 9 times 10 raised to power minus 12 times A, 20 times 10 raised to power minus 4, everything over D. Like I've told you, there will be one letter, one variable for you to find. This time around we are finding D. So putting it together, 9 times 10 raised to the power minus 12 times 20 times 10 raised to the power minus 4 over 0.02 times 10 raised to the power minus 6. We are very sound in indices, which you need to be, because there are some exams you write with their calculators. These things are very simple. I can turn this one to standard form. This is minus 2. It will be added to this one, becomes minus 8. That is indices and standard form working together. So because of time, I have D equals to 9 times 10 raised to the power minus 12 times 20 times 10 raised to the power minus 4 over 2 times 10 raised to the power minus 8 now. I've told you what led to that. So 2 can cancel 2 here, so it becomes 10. So I'll be having D equals to 9 times 10 raised to the power minus 12 times 10 times 10 raised to the power minus 4. Everything still remain over minus 8. Now, the thing is set to 9 times 10 is 90. I'm only working with numbers now. Only numbers, not the family of things. 9 times 10 is 90. I have 90. Now combine according to indices. This is minus 12 plus minus 4. This division is a minus, so minus 8, which means 90 times 10 raised to the power minus 16 plus 8. 90 times 10 raised to the power minus 8. Standard form, this is 9 times 10 raised to the power 1. 9 times 10 raised to the power 1. 1 from minus 8, we have minus 7. So my answer is this. If you are not satisfied with indices or standard form, you can also apply calculator very well. You will get this answer. So, and that is it. That's the end of this series. Now let me now give us a task. If truly you have understood this, I want you to try the next task I want to give to us now. Yes, if truly you have understood what I just taught us today, that we call Capacitors Part 1 or Series 1. If you have understood very well, please do well to subscribe to our channel. Press your notification button, like and share. Please put your comments in the comment section. Put your name there. Let's celebrate you. Let's mention your name on the platform that you are part of us. Now, answer this question. Put the answer in the comment section. Put your name there. If you are right, your name will be mentioned that so you are right with the task we have given you. You may be wondering that what about if you are not right? We won't mention your name. We will private chat ourselves and correct ourselves. Thanks for being there. It's still your physics tutor, Estimator Adetunji. See you in my next video. Bye for now.